This lesson is an introduction to the Citizens Broadband Radio Service, abbreviated CBRS. After the completion of this lesson, you'll be able to describe Citizens Broadband Radio Service similarities and differences from traditional 4G LTE services. Explain how the shared spectrum methodology provides 3 tiers of access to the CBRS RF spectrum. Describe each of the 3 tiers along with their uses and access capabilities. Describe the role of the Spectrum Access System in the CBRS operations, and explain CBRS device types and the constraints in which they operate. Citizens Broadband Radio Service, CBRS, is a shared spectrum LTE technology. In most ways, it is identical to traditional LTE. It uses the same back-end technology that drives traditional 4G LTE. The Evolved Packet Core, EPC, is used to provide subscriber access to a mobile network provider services. This includes the Mobility Management Entity, MME, servicing gateways, packet gateways, and the rest of the components of an EPC. The only modification for CBRS is the connection between the eNode B and the user equipment. 2 key methodologies are different for CBRS: the use of a shared spectrum and the newly allocated RF band used for accessing the services. Each of these will be covered in the remainder of this presentation. The CBRS Alliance is made up of a group of technology stakeholders with the goal to develop, commercialize, and foster the adoption of CBRS. Ruckus and many others have been instrumental in driving this technology and the application that supports it. These contributors are working together to establish the necessary requirements for the use of CBRS and to develop certification parameters that ensure interoperability between all vendors and devices. With traditional 4G LTE, each provider or mobile network operator, MNO, uses a unique radio frequency to provide connectivity to its subscribers. In order to achieve this, each MNO must mount antennas that communicate on this unique frequency throughout the coverage area. In the graphic and accompanying table, we see 4 different mobile providers with rooftop antennas, with each providing access to their individual subscribers on separate RF bands. Beyond the requirements of so many dedicated frequency, this model also presents a problem for signal quality. While these antennas are capable of providing high-quality signals outdoors, they have limited penetration inside of the buildings and other dense structures. These are some issues that CBRS is trying to address. Citizens Broadband uses a radio frequency range that is available for both private and free public use. It leverages technology that allows an antenna to provide a single point of access for users of multiple mobile network providers. Instead of managing several different hardware components and network infrastructures, multi-provider connectivity becomes more simplified. This provides benefits for the MNO as well as the end users. For the MNO, the benefits include the potential lowering of infrastructure costs associated to maintaining multiple individual networks. It offloads traffic, particularly indoor traffic, from traditional 4G LTE towers, and because the modification is only to the radio access network or RAN, there is no change to the existing EPC. The end user benefits from the ability to create private LTE networks for better indoor coverage and more methods available for mobile network access. CBRS is a 150 MHz range in a 3.5 GHz LTE cellular band. The FCC has allocated the range between 3550 and 3700 MHz for this function. This is comprised of 50 MHz from bands 42 and 100 MHz from bands 43. The 3GPP has standardized band 48 for CBRS usage. For CBRS, spectrum sharing rules are defined to allow wireless broadband usage while providing interference protection and uninterrupted use to incumbent users. The incumbents, or users that have been using these frequencies in bands 42 and 43, are U.S. military radars, on the ground or at sea, and fixed location satellite stations. Wireless ISPs and Whispers also use portions of this frequency, but will be moved out of the incumbent tier in the future. In the band 48 RF spectrum, a 3-tier sharing system will coordinate spectrum access among the incumbent military radars and satellite stations and the new commercial users. The 3 tiers are Incumbent, Priority Access License or PAL, and General Authorized Access GAA users. What makes CBRS unique in the LTE communications is the shared spectrum model it employs. In this model, CBRS leverages a tiered system to share the limited 150 MHz frequency space. Notice the pyramid shape. This shape is important because it shows the expected usage of the spectrum. While the top tier has the highest priority access, it is expected to see the least use. The bulk of the spectrum usage will occur in the lower tiers, and as we'll discuss later, the middle tier has hard caps to ensure the lowest tier has access. Let's take a quick look at these tiers. At the top is the incumbent tier. It has the highest priority of CBRS spectrum access. These are the incumbents, or the groups that have been using these frequencies in bands 42 and 43 prior to reallocation. As the highest priority tier, they can access any portion of the frequency at any time. The next two tiers are brand new. They were defined for allowing public access to this shared spectrum. In the second tier, we have the Priority Access License, or PAL users. This license allows at least a 10 MHz channel in a specific geographic area for dedicated use. While theoretically a PAL's 10 MHz channel could be taken over by an incumbent, the allocations of channels based on known data makes this scenario highly unlikely. The lowest tier is the General Authorization Access, or GAA tier. It provides free public access to the CBRS spectrum. Therefore, any channels within the spectrum that are not used by incumbents, which are rarely used, or PALs, which are capped to 7 of 15 10 MHz channels, are available for public use. Essentially, and this is the most important point, each tier is subject to override by the tier above it. However, the expected usage of each tier should provide fair access to all tiers when operating under normal conditions. Now let's take a look at the channel usage in the CBRS spectrum. The incumbents at the top tier are allowed to use any of the channels in the spectrum at any time. But please note this technology is geographically based, meaning these frequency bands are monitored and limited separately in each relatively small geographic area. So these incumbent users and their frequency usage in an area have been being used for many years and have become relatively predictable in their behavior. This opens the door for the next tier down, the PAL tier. The PALs are only allowed to operate on 10 of 15 channels within the 3550 to 3650 MHz range. However, within those 10 channels, only 7 PAL licenses will be granted in any one geographic county level. And finally, we have the GAA tier. Like the incumbents, the GAA users are allowed access to the entire spectrum. However, because this is a tiered system, they may only use the channels not in use by the upper tiers. This graphic is a simplistic representation of the frequency usage between tiers. Within the incumbent tier, there are multiple users, and each one is allocated a subset of channels they can operate in. We'll cover more on this topic later in the course. Here we have the incumbent tier users. Remember, these are the groups that have been using the frequencies in the 3550 to 3700 MHz range prior to the reallocation of portions of band 42 and 43 into band 48. The first group is the military shipborne radar. These operate in the 3550 to 3650 MHz range in coastal areas. Currently, there are only 19 ships with current generation radar in the world, and about 75% of this total have home ports in North Fork, Virginia, San Diego, California, and Seattle, Washington. Future ships are expected to be deploying next-generation radars that will not impact the CBR space. Next, we have military ground-based radar. These operate in fixed locations and occasionally perform in-band operations in the 3650 to 3700 MHz range at 3 sites: St. Indicos, Maryland, Pensacola, Florida, and Pascagoula, Massachusetts. Most U.S.-based military radars operate below 3500 MHz. However, we have seen in-band operations at 41 sites around the country. Again, these are fixed locations, so they only impact lower-tiered users in that specific coverage area. Receive-only fixed satellite service earth stations operate in the 3600 to 3700 MHz range. In-band, there are 35 sites around the U.S., which are mostly coastal sites. These are also fixed locations, so CBRS rules for spectrum allocations should be fairly predictable. And finally, we have the wireless broadband services, which are only allocated to operate in the 3650 to 3700 MHz range. There are thousands of these around the country, mostly in rural areas. Current plans are for these to be transitioned to PAL or GAA operations in 2020 for most providers, with the remaining transition by 2023. However, as of this recording, FCC legislation for this is still ongoing. This is a quick overview of the shared spectrum methodology, which is designed to ensure critical incumbent access is always available when needed. The key takeaway here is that the incumbents have priority access to the entire CBRS spectrum. However, while high in priority, they are expected to have the least requirements for access across much of the United States. As stated earlier, users of this tier are primarily made up of United States military functions, including radar and ground stations. The wireless ISPs still reside here for now, but will be demoted to lower tiers in the near future. As the top tier, they override the PAL and GAA users, and anytime they speak or use any CBRS channel, the lower tier users must cease. However, under normal conditions, outside of known locations where incumbents are present, much of the CBRS frequency range should be available to PAL and GAA users with a very low probability of interruption. Tier 2 PAL users have the next highest priority access and are protected from GAA users. Current FCC legislation allows each PAL license to cover a 10 MHz channel for a single country for a 10-year term. The image here shows sample usage of the CBRS spectrum for a single geographic parcel. The PAL shown in blue can only operate in the 3550 to 3650 MHz range. In this range, we also show incumbent usage, shown in red, on the first channel. Therefore, the 7 priority access licenses, which is the maximum allowed, are assigned other channels in the range. The remaining channels that are not in use by incumbents or PALs are available for general authorized access users, shown in green. Example use cases for priority access licenses include private LTE networks, capacity offload networks for existing wireless service providers, QoS-managed enterprise networks, utility networks, neutral host, wireless broadband service backhaul, and backhaul. And finally, the lowest tier GAA users are permitted to use any portion of the CBRS band, which is band 48, not assigned to higher tier users. With an open access rule, GAA provides free access to the spectrum similar to unlicensed spectrum. Since PAL licenses are limited to a maximum of 70 MHz or 7 channels in any given country, 80 MHz or 8 channels are guaranteed to be available for GAA use if there is no incumbent usage. If there are fewer than 7 PAL leases assigned, GAA users could begin using those channels as well. Of course, if an incumbent begins using any of the frequencies, the GAA or the PAL user must stop. Therefore, theoretically, all 15 channels could be used by GAAs if there is no incumbent or PAL usage. Some examples of general authorized access uses include private LTE, personal and small business hotspots, campus hotspots, PAL offload during periods of incumbent activity interrupting PAL spectrum, unprotected capacity or offload for established wireless providers, wireless broadband services, and backhaul. While GAA operation does not require a costly license, GAA operators must coordinate their use of the spectrum through the dynamic spectrum sharing system. We'll be discussing that next. Before we can talk about how all this access is coordinated, we have to discuss the 3 key role players in the CBRS operations. First, there is the Spectrum Access System, or SAS. This collection of servers all over the country are responsible for maintaining databases of CBRS spectrum usage throughout the entire United States. This includes users from all 3 tiers, incumbent, PAL, and GAA. When you consider the number of parcels for PALs alone, you can probably imagine how much data management this entails. Next is the Environmental Sensing Capability, or ESC. This functionality is critical for the detection of incumbent users. Remember, incumbents can begin operating at any time, and any lower tier users in the channel space are required to stop transmitting on their frequency immediately. When a Tier 1 signal is detected, the ESC will alert the SAS, which in turn will send a signal to devices using the frequency, informing the requirements to relinquish it. These end devices are called Citizens Broadband Radio Service devices, or CBSDs. A CBSD is any device that communicates in the CBRS frequency range of 3550 to 3700 MHz. The term CBSD applies to antennas as well as end-user devices. Details on each of these components and examples of their operation will be covered in the next portion of this presentation. CBSDs are devices that operate in the PAL or GAA tiers of CBRS. Again, incumbents have free rein within the CBRS spectrum and are not necessarily required to comply with these guidelines. First, we have Category A CBSDs. These are your access points, femtocells, and similar small low-power base stations. These are typically indoor but can operate outdoors with a cap on height above average terrain, abbreviated HAAT, which is limited to 6 meters. It has a relatively lower antenna equivalent isotropic radiated power, or EIRP, allowance when compared to Category B devices, which is limited to 30 dBm max. Category B CBSD devices are for outdoor use only. These have a maximum EIRP of 47 dBm. Then we have end-user devices, EUD. These are your average handsets. Think smartphone devices that operate on CBRS frequencies. They have a maximum EIRP of 23 dBm and are not allowed to operate in a peer-to-peer manner. Each of these device types, CBSDs and EUDs, must be capable of two-way communication on the allowed frequency or frequencies. And each CBSD has location requirements that must be met. They must be accurate within a plus or minus 50 meters horizontally and plus or minus 3 meters vertically. And if they move outside of those parameters, they must report the new location parameters to the SAS within 60 seconds of being moved. FCC rules require a CPI, or a Certified Professional Installer, deploy most CBSDs. Finally, all CBSDs must comply with directions from SAS within 5 minutes. This may include orders to stop transmitting due to incumbent activity or instructions to lower antenna output power. A Certified Professional Installer is a new certification specified by the FCC to ensure CBRS radio location and related parameters are correctly entered into the SAS to maintain the integrity of the spectrum sharing model. FCC rules for CBRS deployment require a CPI for the majority of CBRS radio transceivers or Citizen Broadband Service Devices, CBSDs, deployments. CPIs ensure CBSDs lawfully operate within the designated spectrum of the CBRS. A CBSD's location information must be recorded at the SAS as part of the CBSD registration process. Location determinations may be carried out via automated geolocation technologies or may be entered into the SAS by a professional installer. Any subsequent CBSD movements shall be reported by a professional installer as well. CPIs receive training in the relevant Part 96 rules and associated technical best practices. CPI training programs take less than a day to complete and result in a certificate that can be used for any CBRS installation on any SAS with any CBSD device. When a CBSD powers on, it must register with the SAS before ever transmitting on any CBRS frequency. On power up, the CBSD will send registration information to the SAS that includes GPS location and antenna height. GPS coordination is used to determine exactly where the device is located geographically. These coordinates must be accurate within plus or minus 50 meters horizontally and plus or minus 3 meters in elevation. The device must indicate its device category. This will be either A or B, and based on the category, must operate with the conditions that were previously discussed. They must provide the requested authorization status of PAL or GAA, and PAL devices will be required to provide information that authenticates their PAL status. The FCC identification number, which informs the SAS the device is confirmed to operate within FCC-specified technical standards, as well as any sensing capabilities if supported to assist in ESC functions. Other additional information is also provided but is beyond the scope of this presentation. Once the CBSD information is received, the Spectrum Access System, or SAS, evaluates the information and determines if the device will be granted access. This will be based on several factors, including but not limited to channel activity, validity of PAL claim, and FCC compliance. If all requirements are met and channels are available, the SAS will send authorization. This will include information like the authorized channel to use and the maximum power level in which the device can operate. While the CBSD is in operation, the SAS may send commands to the CBSD that it is required to comply with. These may include orders to change frequency, perhaps due to incumbent activation, or power level adjustment due to the proximity of another active antenna. Here we have a usage scenario where PALs occupy their maximum of 7 channels in the CBRS spectrum. There are also 5 GAA CBSDs active, leaving 3 channels open. Suddenly, an incumbent Navy shipborne radar becomes active on the 3570 and 3580 MHz channels and is detected. The ESC will detect this usage and report it to the SAS, which has a database of all channel usage. This will result in the SAS instructing CBSDs to change their frequencies. Once this instruction is received, the CBSD is required to complete the change within 5 minutes. Since one of the channels is used by a PAL, the SAS instructs the PAL CBSD to move to a different frequency. In this scenario, the only frequencies the PAL is allowed to operate in are occupied by the GAA users. Therefore, the GAA users are also instructed to move to a different frequency. If no frequencies are available, the GAA device would not be allowed to transmit until a channel opened up. But in this case, a channel is available and the GAA CBSD moves. When the incumbent stops transmitting, the channels reopen and standard Tier 2 and Tier 3 rules are applied to open channels in the spectrum. Here we have a brief summary of the components of the CBRS Shared Spectrum Access Management. First, we have our 3 tiers. Tier 1, shown in red at the top of the image, is the incumbents, or those users that have been active in these frequency ranges prior to the 3GPP certification of Band 48. These users have the highest priority access to the spectrum and are primarily made up of U.S. military operations. While wireless ISPs are currently assigned to the tier, they are expected to be reallocated to the lower tiers. The new entrants into the CBRS spectrum make up the lower tiers. Tier 2, shown in blue, is for priority access license for PAL users. These users bid for licenses that grant guaranteed access to the spectrum under normal operating conditions. Tier 3, the lowest tier, shown in green, is used for general authorized access or GAA users. This tier provides free public access to the CBRS spectrum. The allocation of spectrum channels and the projected infrequency of the incumbent's use was designed to ensure fair access to the spectrum for all 3 tiers. The coordination of all these users is the responsibility of the Spectrum Access System, or SAS, with assistance from Environmental Sensing Capability, or ESC, devices. The SAS manages all spectrum access and determines when and where a Citizens Broadband Radio Service device, or CBSD, may operate. It allocates channels to CBSDs based on geographic coordinates obtained through GPS information and a database of all active channels. The ESC is responsible for informing the SAS of incumbent activity. When incumbents are detected, the ESC alerts the SAS, and the SAS reassigns lower-tier users as necessary. Let's summarize what we've covered in this lesson. In this lesson, you've learned that CBRS, unlike traditional 4G LTE, allows providers to share one antenna and 150 MHz in the 3.5 GHz spectrum instead of requiring each to operate in an individual unique RF spectrum. Shared spectrum technology ensures top-tier, often infrequent users are guaranteed access to the CBRS RF spectrum range, while still offering relatively insured access to middle-tier users and leaving the remaining bands to general access users. The CBRS system is managed by the Spectrum Access System, SAS, that allocates bands to CBSD devices by maintaining a database of used frequencies in a coverage area. CBSD access devices are classified by category A or B, where A devices have low HAT and are typically classified as indoor, and B devices are designated for outdoor usage. Each CBSD device type has restrictions on installation requirements and operating power levels. FCC rules for CBRS deployments require a Certified Professional Installer, a CPI, for the majority of CBRS radio transceivers or CBSD deployments. Thanks for taking the time to view this training lesson.